Hey guys, what's up? I'm going to be recording today another paper which is Winter 21 question paper 1 2. Okay, so let's just begin immediately without wasting much time. Which row shows what all physical quantities must have? Okay, so physical quantities must have a magnitude, must have a unit. Direction is not that necessary unless it's a vector quantity. Anyways, the magnitude must be there and the unit must be there. So obviously this is going to be, but the direction is not that necessary. So C is going to be the right answer. Let's just move on to the next part. And okay, what is an alternative way of expressing an energy of 43 decijoules? So 43 decijoules is going to be multiplied by 10 raised to power minus 1 joules. Deci stands for 10 raised to power minus 1. So I'm just going to convert this into 4.3 joules. Okay. So what I'm going to be doing now is that I'm going to be matching up all these values over here. You can clearly see that. And I'm going to be converting these to joules. And let's see where we stand. The first option, let's just look at this thing. So 4.3 into 10 raised to power 3 multiplied by 10 raised to power minus 3 joules. So A option, this is just simply going to cancel out. So this just goes away. And so we are left with 4.3 joules. So yeah, apparently the very first choice is the right answer. I don't need to move forward anymore. Let's just look at the third question. A tennis ball is hit so that it leaves the racket with velocity v at an angle theta to the horizontal. The vertical component of the velocity is vy. What is the magnitude of the horizontal component of v? Okay, so this cannot be v sin theta, तो पहला वाला तो ऑप्शन गलत हो गया. But what about this one, B1? No, B1, because it is referring to Vy over here, so this doesn't work that way. It has to be V cos theta, but apparently we don't have V over here, it's Vy. So this is also the wrong answer, Vy obviously wrong. So we are just left with one option over here, which makes sense. The reason is that, let's suppose our target is to find, let's suppose Vx. So this should form a triangle over here, bete. This should form a triangle which is Vy. So V square is equal to Vy square plus Vx square. And our target is actually Vx. So Vx should be equal to V square minus Vy square, and then we happen to have an under root sign over here. So apparently this under root definitely means x raised to power half. So mathematically this should be the right answer. Next step, question 4. 4 cathode ray oscilloscope screens each display a waveform. The screen and the time base setting of each CRO is shown. Okay, time base is given as point. What do we have to do for? Okay, the question is written here. Which screen shows waveforms of the same frequency? Okay, so we apparently need to find the frequencies of all these. Let me just find my calculator first of all. Okay, so one of my students, Samir, has given me a calculator to solve this part. And let's just look at this thing. सबसे पहले हम लोग इसमें time period निकालेंगे और उसके बाद we will have to convert this into frequency. So let's see, 4 boxes over here. So इसकी तो हमारा time period आ जाएगा. So I'm just going to be doing it very quickly. So frequency should be equal to 1 over time period, and for this one we are just going to be using 4 blocks. So 4 blocks would mean 0.02 multiplied by 4 blocks, and that gives me 0.08. So 1 divided by answer should give me 12.5 hertz. That is 12.5 hertz. Let's just look at the option number 2. Okay, apparently I can just be sure about this. If I get the same time period over here, that means the frequency remains same. So we just need to prove it. I don't even have to find the frequency anymore. I can just verify the time periods. If the time periods are same, that means the frequency remains the same. So let's just look at the second option. That is going to be 2 blocks. So that is 0.08. So yeah, This one also seems to have the same frequency. This one has the same time period of 0.08. So 1 and 2. So 1 and 2 should be the right answer, but let's just check third option. That is going to be 0.01 multiplied by 2 because we have 2 blocks over here. So that gives me a value of time period 0.02 seconds. So this is wrong. So obviously this is going to be wrong. So the first two options are correct. पहले दो सही है, A option. Let's just look at this question. A student measures the time for one complete oscillation of a pendulum of length L. Pendulum जो होता है वो left to right हिलता रहता है. Her results are shown in the table. Pendulum is a her. No. A student is a her and she happens to have a pendulum. And her results are shown in the table. Okay, so we have the length over here with its absolute uncertainty. We happen to have the time period over here with its absolute uncertainty. And she uses this formula, but then again, if the physical quantities are multiplied and divided, we have to work with percentage uncertainties, not the ABS uncertainties. So first step is finding the percentage uncertainty, which is 0.001 divided by 0.420 multiplied by 100, and that gives me a percentage uncertainty of 0.23. मेरे प्यारे बच्चे 2 मिनट इधर आओगे. इस कैलकुलेटर के अंदर मेरे पास जो है वो बहुत सारे जीरोस आ रहे हैं. इसको फिक्स मोड से इसको नॉर्मल मोड पे करके दो मुझे जल्दी से. So yeah, 0.24%, and we happen to have 0.1 divided by 1.3. I hope the recording is turned on. Yep, it is on. It is on. The calculator does not even have a screen. What kind of calculator is this? इसमें तो आधा नजर ही नहीं आ रहा.
आंसर सही आएगा सर.
तो आंसर जब मैं रीड ही नहीं कर सकूंगा तो कौन सा आंसर सही होगा?
सर आई डोंट नो.
हाँ?
आई डोंट नो.
Well, 7.69%. So yeah, she uses the formula this to calculate the acceleration. What is the best estimate of the percentage uncertainty? So best as in the value of G. So we need to make G the subject first of all. That is the most important step. So let's just square everything so that I can free up G over here. So this becomes 4 pi square and this becomes L over G. So G is actually equal to 4 pi square L over T square. And after this operation, we just need to find the percentage uncertainty in G, and that should be we just have to ignore the constants, your dimensionless constants. We will ignore that. Sorry. And L में कितनी है percentage? 0.24 plus, since T has a square, so the value, the percentage uncertainty of T must also be multiplied by 2. So 2 multiplied by 7.69. If we do this careful operation, we should be able to find the right answer. 0.24 plus 2 multiplied by 7.69, and we get a value which is not even in the answer list. Well, apparently it is. It's 15.6%. So 15.6% means the closest value is actually 16%. So this should be the answer. Let's just move on to next drama question. The graph shows the variation with T of the velocity of a vehicle moving in a straight line. The vehicle tends to be moving in a straight line. The vehicle moving at 4 meters per second begins to accelerate at time t is equal to 0. You can clearly see that the gradient is changing. The gradient is initially flat and then it is increasing. That means the value of acceleration is also increasing. And the question is, what is the vehicle's acceleration at time t is equal to 3 seconds? So we have to find the instantaneous acceleration. And for instantaneous acceleration at this particular point, we need to draw a tangent. That is the only way. I hope it's called tangent or tangent.
टेंजेंट जो है
जो भी है, पाकिस्तानी हम लोग. So let's just draw a tangent. And we'll work this out. Well, we just need an estimate, so it makes no difference at all. But I'm just going to be drawing this tangent, and I'll just make myself very, very smart over here. And I'm going to be finding the values. This coordinate I'm going to be using, and I'm also going to be using this coordinate. So this becomes 6, 10. And this becomes 0, 2. So gradient is 10 minus 2 divided by 6 minus 0. So 8 over 6. And let's see what the answer is. 8 over 6 is actually 1.33. So the closest estimate is this C option seems to be the right answer. So far the paper is relatively easy. I scared you at the very beginning that the paper is difficult, but it is not. If you have a brain, you will survive. If you don't have a brain, you will not survive. It's that simple. You have to prove yourself that either you are a horse or a donkey. Anyways, question number 7. A stone is projected vertically upwards from the ground at an initial speed of 15 meters per second. Okay. So apparently a stone is thrown upwards at an initial speed of 15 meters per second from ground, and we have to draw the ground over here. The stone tends to go up. At air resistance is considered negligible, so we can use the equations of motion. What is the maximum height reached by the stone? And for this height, we have to find this height. And we know that the velocity at the maximum height is actually 0. And it was thrown initially upwards at 15 meters per second. And we have h, and the acceleration is taken as minus 9.81, because if we are moving upwards, the acceleration should be negative because the force of gravity is downward. We can simply use v square is equal to u square plus 2as and be done with this question in a second. Our target is to find h, so h is going to be s over here because that is the displacement. So final velocity square is equal to initial square plus 2 times minus 9.81. If you're going to take this as positive, then be ready for a disaster and you will get a poor grade if you make this mistake. Don't make this mistake and follow my advices. Divided by 2 divided by minus, my God, what is this calculator? I'm pressing the braces sign and it is coming as, it is not working. Okay, so the calculator functions have malfunctioned. Apparently, a child here threw water on it and it shows that electronic items tend to fail. So make sure you don't drink water. बेटे आपका रोज़ा नहीं है क्या?
क्यों?
इससे आपने पानी कहाँ से लेकर आए इधर? Anyways, 2 divided by brackets में minus 9.81. Well, we have a malfunctioning calculator and the child apparently just threw away this calculator. उसको लगा कि यार ये किसी काम का नहीं है, लेकिन हमारे काम तो आ रहा है. So 11.5 meters. नहीं, actually, if I round it off, this is going to be two significant figure, 11 meters. Actually, it was 11.46, so 11 meters. So we have to go with B option over here. What is meant by the mass of an object? क्या होता है mass? इसमें से select करो. D. बेटे mass weight होता है. बेटे यार ऐसा नहीं करो. this is not the right way to do it. Let's just do the
B कुछ तो हो गया
huh?
C हो गया और क्या होगा
The property of what is meant by the mass of an object? The property of an object that resists a change in motion. That is actually inertia. This is inertia. The pull of the earth on the object. Oh, bhai, that is gravity. So that cannot be true. The total number of atoms in an object. That is absolutely true. The amount of matter in an object. So this must be true. The weight of an object is the wrong answer. So C should be the right answer. Okay, this one is interesting. This is something that you guys can also use your brain and use it. So what if you are I'm so sorry. The diagram shows two parachutists X and Y moving vertically downwards. The total mass of parachutist Y and his parachute is twice the total mass of parachute X and his parachute. अच्छा, इसका mass हमारे पास M है. So apparently this has 2M. At this moment, the air resistance on parachute Y is twice the air resistance on parachute X. Let the air resistance be Fr and let the air resistance over here be 2Fr. Okay. Neither parachutist has reached his, wait a minute. Guys, sorry for the disturbance. At this moment, the air resistance on parachute is twice this. Neither parachute has reached its constant terminal velocity. Okay. This statement describes the acceleration Ay compared with the acceleration of x. So we need to find the resultant force. Let's just do this part. अगर हमारे पास यहाँ पर लिख लें mg, so that is going to be the weight, and we can also write mg over here. So let's just look at this option. This is going to become the weight is obviously mg minus fr is equal to mass into acceleration, and this is the equation that is going to be valid for option X, and for option Y this is going to be 2 times mg minus 2 times fr, which is going to be 2 times m multiplied by a. So in short, the 2 is cancelled out completely. Mg minus Fr is equal to Ma. So we have it. We can see that both the equations are perfectly the same. The acceleration of y is half the acceleration of x. No. The acceleration of y is the same as the acceleration of b, because there is no difference in the final equation. If you open your eyes, you are going to notice that both the equations are exactly the same. So why would there be any difference in its motion? It has to be the same motion. Okay. Oh my God. The table shows 4 different collisions between 2 blocks, each of mass 0.50. Which collision is perfectly elastic? Well, for elastic collisions, I taught you guys a method known as the law of restitution. We are just going to use that law of restitution, and for that you have to come and study with me at my place, and that is CI Network. Nevertheless, I'm just going to be solving this using the idea of the law of restitution. That means the relative velocity of approach must be equal to relative speed of approach must be equal to relative speed of separation. So let's see. This 4 is approaching. When we talk about before collision, they are approaching each other. This is actually stationary. So this is going to be 4. And after the combination, they are moving at 2. So no, they are not equal. So this one is wrong. Yes, look at this thing. During approach, they are approaching. So if they are approaching, the speed should add up, and this becomes 4, and this is 0. So this does not match. This becomes 2 plus 1, that is 3. And this becomes 2 plus 3, because during separation after collision they are supposed to be separating, and if visually they are separating, so the speed should add up, and that becomes 5. So this does not match. Obviously the last answer would be correct. You can clearly see that 4 is approaching this 1, but 1 is supposed to be on the left hand side, so this becomes 4 minus 1, and that becomes 3. Similarly, one of the direction has actually reversed, so this is also 3. So obviously D should be the right right answer? Well, apparently you have no idea. आप जो इतने परेशान हो रहे हो, the reason is that because I just used the law of restitution over here, which is not a part of O-level syllabus, my child. I directly use it, but you can also solve it using the kinetic energies as well. The kinetic energy should be the same before and after to prove it. You can also do that method. That will be long. You will be spending the entire time of your paper solving that each and every part, and you can see that D is the option over here. So it will take a long time. It is going to waste half an hour, and you will run out of time, and you will panic, and maybe you will collapse during the paper, and then you will have to repeat, rinse and repeat the paper again in October, November session. So don't do this mistake. Anyways, a cylindrical block of wood has cross-sectional area A and the weight W. It is totally immersed in water with its axis vertical. The block experiences pressure PT, which should be pressure at the top, and PB. Okay, it is given top and bottom surface respectively. What is the upthrust on the block? Upthrust is basically pressure is equal to force per unit area. So force upthrust F up is equal to change in pressure at the top and the bottom multiplied by area. So change in pressure multiplied by area. So B should be the right answer. That was simple. Okay. Upthrust is not the resultant force, so we cannot minus the weight or add the weight to it. Two forces each of a magnitude F act on a disc of diameter S as shown. What is the torque exerted on the disc? Okay, the torque should be, it's just a couple, for God's sake. It's a torque of a couple. So F multiplied by S should directly be the answer, because this is actually the torque of a couple. It's a couple. Basically, we have two forces which are exactly equal in opposite in direction, and we happen to have a perpendicular distance between the two forces. So torque of a couple, and that is actually F into S. C option directly. Okay, the mass of 500 gram is attached to one end of a rod of length 1.50 meters. The rod is pivoted at a distance of 25 centimeters from the other end. Okay, so one of the value is given in meters and the other is given in 25 centimeters. Though that is, fooling us. The rod is horizontal. What is the moment about the pivot due to the mass? Okay. So we just have to find the moment about the pivot due to the mass alone, right? So moment should be equal to the mass is 500 divided by 1000 to convert this into kilogram, and then multiply by 9.81. That makes it the weight, and that is acting downward, and multiplied by the perpendicular distance from the pivot, and that should be 1.5. Wait a minute. That is going to be 1.5 minus 0.25, and that should give me the value. Let's just find out. So 500 divided by 1000 multiplied by 9.81 multiplied by brackets में 1.5 minus 0. ब्रैकेट्स तो है ही नहीं ब्रैकेट तो है ही नहीं इसमें. How do I use the bracket over here? मैं कर रहा हूँ. ब्रैकेट तो काम ही नहीं कर रहा इसमें. Find this answer. Actually मैं सिर्फ 1.25 कर लेता है तब भी आ जाता. So 500.
मैं कर रहा हूँ सबर करें.
उसको नजर नहीं आता.
बस देखिए सही दे रहा है बिल्कुल सही दे रहा है. 6.155.
कितना?
6.155.
6.155 Newton meter. So C should be the right answer. Wow. So I'm going to be taking a break, and after that we are going to continue with more questions. Okay, guys, I'm back. Now you can look at the time. So I took a huge break and now I'm back with this question. Let's see. Question number 14 है. A beam QR is held in position by a wire PQ. ये PQ है जो इसको बचा रही है नीचे गिरने से किसी के ऊपर. The structure is used to form a crane supporting a stationary load of 4 kilonewton. Okay. What is the force exerted by the beam QR on point Q? हमें निकालना है कि इधर ये जो तारें लगी हुई हैं ये क्या फोर्स इस पे एक्सर्ट कर रहे हैं. व्हाट इज द फोर्स एक्सर्टेड बाय द वायर्स ओवर हियर. सो फर्स्ट ऑफ ऑल लेट्स जस्ट बिगिन डूइंग इट एंड लेट्स सी वेयर वी स्टैंड. फर्स्ट ऑफ ऑल वी हैपन टू हैव अ फोर्स डाउनवर्ड्स. सो दिस एंगल इज गोइंग टू बी 60 degrees and we happen to have a force over here as well. यहाँ पे भी एक फोर्स होगी. लेकिन हम लोग एक काम कर लेते हैं. सबसे पहले इसको रिजॉल्व करके लेट्स जस्ट फाइंड सम कंपोनेंट्स ओवर हियर. फर्स्ट ऑफ ऑल आई एम गोइंग टू रिजॉल्व दिस कंप्लीटली. अगर मैं इसको रिजॉल्व करना चाहूँगा तो दिस फोर्स मस्ट बी इक्वल टू वॉट एवर दैट इज. मैं इसमें जो है ना मैं एक काम कर रहा हूँ इसके अंदर मैं इसी को पूरे रिजॉल्व कर लेते हैं. लेट्स जस्ट ट्राई रिजॉल्विंग दिस in this direction and also this in this direction. So this is what I have a plan of doing. So let this be the T force and let's just find it out. So T sine 30 should be equal to, this is actually 60 degrees. So let's just find this force and wait a minute. Wait a minute. There is a problem. There is a problem. We happen to have a serious problem over here. And that problem cannot be resolved that easy. Okay, got it. The idea is that we will resolve this in this direction and this direction. मैं दोनों को इस तरीके से resolve करके जो ये force होगी वही ये force होनी चाहिए. So apparently let this be T force. So T sine 30 should be equal to this is 4 Newton, so 4 kilonewton. So 4 this is actually 60 degrees, so 4 sine 60 degrees. So yeah, so we have arrived at this point and let's just find T first. So 4 sine 60 divided by sine 30 gives me this force as 6.93 kilonewton. So we have this as 6.93 kilonewton. And now it's just a matter of resolving it. अब resolve तो हो चुका है. अब resolve के बाद हम लोग एक next step पे चल रहे हैं. Just imagine this thing कि ये दो forces जो है ना, this 4 kilonewton force is actually acting over here in this direction and this 6.93 is acting this way. So apparently this forms a triangle of forces and we can find the resultant force that these wires exert. तो वो वाली जो this beam is going to exert a force in this direction. So in short, let's just use the Pythagoras theorem to find the force exerted by the cables on this beam, and that should be 6.93 squared plus 4 squared, and we will also apply the root operation and that should be the resultant force, and that should be equal to almost 8.00 kilonewton. So this should be the answer. T should be the answer. So this is done. Let's move on to the next question. Oh my god, a metal cylinder totally immersed in water is hung from a Newton meter. Okay, the cylinder of height L is slowly raised vertically by lifting the Newton meter. Okay, slowly. Okay, as the base of the cylinder moves from line X in the water to line Y. Okay, so we have actually raised it out of the water. The reading R on the Newton meter is recorded. The velocity of the cylinder is constant. So that is one very important point. That means the upward force must be equal to the downward force at all times. Which graph best shows the variation of R? And R is the reading on the Newton meter, okay, with the distance d of the base of the cylinder from line X. So let's just, first of all, initially, R is the reading on the Newton meter. So apparently, we can form an equation over here. This is R. If this is R and R, there is an upward force acting over here, which is the upthrust, and upthrust UP should be equal to the weight. Weight is acting downwards, and there is definitely a force upwards, which is known as the upthrust. So this must be equal to W. Okay, this is the first phase, and apparently R is equal to W minus the upthrust. Okay, so this is what we are going to be doing. At this position, initially, since weight is not changing and the upthrust is also constant, and they tend to cancel each other out, so R must be 0, and in fact, so R must be constant. If weight is not changing and if the upthrust is not changing, तो R तो हमारे पास 0 होना चाहिए था. So R should, एक minute, R cannot be 0. I think I made a mistake in forming the equation. Actually, my logic, my thinking was absolutely correct. This is the equation that we get. But remember this thing, the total upward force is this. R plus the upthrust is equal to weight. This must be constant, okay? For the velocity to be constant. So therefore, we have this situation over here where the upthrust is actually less than the weight. Okay? यहाँ तक तो पहुँच गए. And फिर हमारे पास क्या है? The R should definitely have a value which is going to be constant throughout. क्योंकि हमारे पास ये शुरू में constant रहेगा. So this cannot be true because R is actually changing at the start. So this cannot be true. At least till this point. So C or D could be correct. So this could be correct or this could be correct because R is apparently constant as long as it is in water. And immediately after that, we realize that it is being raised out of the water. If it is being raised out of the water, the upthrust tends to falls down. The upthrust will start decreasing. If the upthrust starts decreasing, so R must increase. R must definitely increase, so R is going to be increasing, but since we are maintaining a constant speed, so this should be the right answer. Immediately after being raised out of the water, then R becomes equal to the weight again to maintain constant speed, so this must be a straight line. So C is the best answer. It cannot be a curve because the velocity is completely constant. So this should be the right answer. Next question. A ball is thrown vertically upwards into the air. It rises to the top of the path before falling to the vertical, before beginning to fall vertically downwards. Okay. Assume that the gravitational potential of the ball is 0 at its starting position. Okay. Which statement about the ball is not correct? Okay. So we need to find which statement is actually false. As it rises, its kinetic energy is transferred to gravitational potential energy. That is absolutely correct because we happen to have the kinetic energy, and this kinetic energy starts decreasing because the speed starts decreasing, and this is being converted to GPE. That is correct. Okay, at the midpoint of its path, its gravitational potential energy is equal to its initial kinetic energy. That cannot be true. The reason is that the acceleration is actually, there is an acceleration involved and therefore the speed is not constant. तो ये तो हमारे पास नहीं हो सकता, but still let's just keep it this way. Let's just read the other points as well. At the top of its path, its kinetic energy is 0. That is also true because the speed is actually 0 because this is the turning point. At the top of its path, its total energy is less than the initial total energy. Okay, now that is important point. It has written air, upwards into the air. So if there is air, इसका मतलब है कि हमारे पास some energy is bound to be lost as work done against friction, as work done against air resistance. So definitely the total energy is less than the so its total energy is less than its initial total energy. Yeah, definitely it is actually true. So B should be the right answer because there are apparent losses over here. Anyways, an object slides with constant velocity across a horizontal sheet of ice. Friction is negligible. A constant horizontal force of 2.1 Newton is then applied to the object as shown. Okay, my God, an object slides with constant velocity across a horizontal sheet of ice. Friction is negligible. A constant horizontal force of 2.1 is then applied to the object as shown. Okay, that is understood. A short time after applying the force, the object reaches point X. Okay, so it reaches this position at a displacement of 4 meters from its position when the force was first applied. What is the work done by the force on the object as it travels to point X? So we need to find the force in this direction. If I find the force in this direction and multiply it by 4, that should give me the work done. So let's see. We happen to have a constant force applied in this direction, which is actually 2.1 Newton. And what we need to do is that we need to find the force over here. So let's see. If we form a triangle over here, if this is 2.1 Newton, then what would this force be? We need to find this force. So cos 30 should be equal to 2.1 divided by F. So the force F is actually 2.1 divided by cos 30. So let me just find it out. 2.1 divided by cos 30, and that gives me 2.42. So this force is actually 2.42 Newton, and we just have to multiply the force into distance, and that should give me the work done. So work done should be 2.42 multiplied by 4, and that gives me 9.68. Nope, I made a mistake. 2.42 multiplied by 4. No, I'm 1 minute, there is something else. Then applied friction is negligible. I'm not getting the right answer, but let's just verify it again. Okay, 4 meter है, and I just found that force. So 2.1 over cos 30. 2.42 multiplied by 4. No, I'm not getting the right answers because I'm not getting a value that matches this. So let's just go over it again. Okay, so if I'm not getting the right answer this way, so we have to approach it with a different way completely. And that way is, we can solve this question again. Let me just give it a shot again. This approach was not workable because I'm not getting any of the values over here. So we can approach this question very differently. This force is always acting towards the right. If this is acting towards the right at all times, तो इसका मतलब है कि यहाँ पे भी इधर होगी, यहाँ पे भी इधर होगी, यहाँ पे भी इधर होगी. So what we can do is that we can the actual distance moved in the direction of the force is actually this distance. So we can find this distance, and that should be 4 cos 30. So this is the distance we are going to be using. So 2.1 multiplied by 4 cos 30 should be equal to the work done. If this is the work done, then 2.1 multiplied by 4 cos 30 and that gives me 7.27, which is actually C. C is the right answer. Okay guys, the initial approach that I took was actually wrong. That approach was wrong. Even that approach can work, but there was a problem with the calculations. Let me show you how this can be done again. Okay, I just found this value. You can pause here and you can repeat the same steps again in a slightly different fashion. This is the force 2.1. I need to resolve this force in this direction. Let me show you that direction first. This is not the direction. The direction is actually this way. So yeah, so the 90-degree angle is going to be like this, and now I can resolve it perfectly fine. So therefore this force F should be equal to 2.1 cos 30. That should be the right answer. So 2.1 cos 30 is the force, which is actually F is equal to 1.82 Newton. So this force needs to be multiplied by 4. The distance moved in the direction of the force multiplied by 4 gives me again 7.3. So that is correct. Okay. I made a mistake in that because I considered this. So that was not actually resolving this 2.1 Newton, because this was a component itself. Resolution should always be done in the way that I have described right now. I made a mistake initially, okay? So I hope this is clear. Anyways, next step, question number 18. The energy conversion inside a power station burning fossil fuel can be simplified as shown. Chemical energy W, thermal energy X. Okay, chemical goes to thermal and thermal goes to electrical. Which expression gives the efficiency of the power station? The power station efficiency is the total power output over the total power input. So output is Y over the input should be W. So A should be the right answer. The mid step can be skipped altogether. Anyways. Next step. Car X is traveling at half the speed of car Y. Car X has twice the mass of car Y. Which statement is correct? Let's just do this question. Okay guys, car X is traveling at half the speed of car Y, and the car X has twice the mass of car Y. Which statement is correct? Okay, so these talk about the kinetic energies. So we are just going to form some data over here. Let's see. First for car X and then for car Y. Okay, so let's just begin doing it. Has half the speed of car Y, so if let the speed of car Y be V, so this is going to be half V, and after that car X has twice the mass of car Y. Okay, so if this is M, then this is going to be 2M. Let's find the kinetic energies. So this should become half 2M and 1 over 2V whole square. So this becomes 2 cancels out, and this becomes M 1 over 4 mv square. Okay. What about this one? So this is going to be half mv square, and apparently if this is half mv square and this is actually 1 over 4 mv square, so comparing the two values has half the kinetic energy of car Y. That is true. That is absolutely true. So car X has half the kinetic energy of car Y. Very simple. The total weight of the motorbike and the rider is 1800. So that is the weight. The motorbike travels in a straight line at constant speed. Okay, so constant speed it is at an angle of 30 degrees to the horizontal. The useful output power of the motorbike is this. Okay, so this is the useful power output, which is 36,000 watts. The total resistive force due to air resistance and friction on the motorbike and the rider is 2,400 Newton. Okay, this is the resistive forces and the friction. Okay, now the problem is that there is also a component of weight down the slope, and that is going to be acting this way as well, and that is going to be 1800 sine 30. So that is a component that is down the slope. So eventually, since this is traveling at the constant speed, that means whatever force we are getting over here on this side should be equal to the forward force, and we can find the speed of the motorbike. Let's just try this out first. So total force down the slope must be equal to 2400 plus 1800 sine 30. So that should be equal to 2400 plus 1800 sine 30, and that gives me 3300 Newton. So the forward force must also be equal to 3300 for it to maintain constant speed, because we don't want any resultant force. And eventually, what is the speed of the motorbike? So power itself is equal to force into velocity. So power is 3600. Sorry, 36,000 is equal to force. We already have the force with us, which is 3300, and multiplied by the V. So let's just find this value out. 36,000 divided by 3300 gives me a force of 10.9. Sorry, velocity of 10.9 meter per second. So this is the closest answer, so B is going to be the right answer. That does it. Just give me a minute. Okay, next step. 3 springs are arranged vertically as shown. We happen to have 2 springs in parallel and 1 spring in series with P and Q. Springs P and Q are identical, and each spring has a spring constant of K. Okay. So K and K. Spring R has a spring constant of 3K. Okay. What is the increase in the overall length of the arrangement when a force W is applied as shown? Let's do this question. So let's see. W is the load that is applied, and if W is the load, so W is equal to the combined K. First of all, remember this thing, when if the stiffness value increases, and remember this thing, the stiffness value increases when in parallel. So eventually this part, the total K for these 2 parallel springs should be equal to 2K, direct addition, and this is actually 3K over here. So the thing is, the spring constant tends to decrease if they are connected in series. So the total spring constant should be, total K should be equal to 1 divided by 2 plus 1 divided by 3 raised to power minus 1 K. So 1 divided by 2 plus 1 divided by 3 raised to power minus 1, and that gives me 6 over 5K. Okay. So W, which is the load, is equal to 6 over 5K multiplied by the extension. So extension should be equal to 5W over 6K. So 5W over 6K should be the right answer. A is the answer. Okay. Next question. The length of the metal wire is attached to a fixed point and hangs vertically. Masses are then suspended from the wire. Assume that the cross-sectional area of the wire remains constant. Okay. A stress strain graph for the wire is plotted as shown. Okay, so what is represented by the shaded area under the graph? Let's just look at this thing. We can work out the units and find it out. So apparently half of the stress is then multiplied by the strain, and let's just do that. So half into stress into strain should give me 1 over 2. Stress is actually force per unit area multiplied by the strain is extension over the original length. And let's see, if we are multiplying these things, so what do we even get? So half Fe over Al. So this is what we are getting. So the unit is something that will tell us what exactly is this quantity even. So force, okay, let's just look at this thing. So apparently, if we look at it this way, just look at this thing. Force into extension is actually the work done, and area, cross-sectional area multiplied by the length gives us the volume. So work done per unit volume. So it is actually the work done per unit volume. So let's just look at this thing. Strain energy in the wire over the volume of the wire. So volume should be there. So it's D should be the right answer. Okay. So that does it. The table contains descriptions and examples of waves. Which row is correct? Oscillations are parallel to the direction of energy transfer for gamma rays. That is wrong. Oscillations are parallel to the direction for the ultraviolet. That is also wrong. Oscillations are perpendicular because we know it is perpendicular to the direction of the energy transfer. That is wrong. Oscillations are perpendicular to the direction of energy travel. That is correct for X-rays because X-rays is a transverse wave. Okay. A sound wave from a loudspeaker is reflected back along its original path by reflector. Okay. The microphone is initially at point X where the sound intensity is a minimum as shown. The microphone is moved towards the reflector and passes through 4 more intensity maxima until reaching a 5th minimum at point Y. Okay. What is the wavelength of the sound? Okay, so we have M as the minimum points, which are the nodes basically. So node to node is half lambda, and apparently we have, let's just do it this way, half lambda. So there is another half lambda over here, another half lambda over here, and another half lambda over here, and another half lambda over here. So that makes it 1 lambda, 2 lambda, and 2.5 lambda. So wavelength of the sound should be 2.5 lambda is equal to 70 centimeter. So lambda should be equal to 70 divided by 2.5, and that should give me 28 centimeter. A train travels in a straight line at a constant speed of 30. The train's horn continuously emits sound of frequency this. Okay. This is the source frequency. The stationary observer stands next to the train track. The train approaches the stationary observer, so F observed should increase and passes him and then moves away. The speed of the sound is this. What is the maximum difference in the frequency of the sound heard by the stationary observer? So we need to find F naught for both the condition when it is actually approaching and then when it is actually crossed and moving away. So F naught should be equal to, we have to consider both equations. So Fs V over V plus minus V, Vs. Okay. So F naught for approaching, F naught should be equal to, Fs is actually 2400 multiplied by the speed of sound, which is 340, divided by speed of sound 340. Since it is approaching, the denominator should actually decrease, so minus 30. That should give me 2400 multiplied by 340 divided by 340 minus 30. Oh my god. divided by 310. So that should give me a value of 2632. That is, it has actually increased by a certain amount from this value. So let's just find what is F observed for when something is crossing and moving away. So 2400 multiplied by 340, and that should be 340 plus 30. So 2400 multiplied by 340 divided by that should be 370, and that gives me 2205. Okay, so what is the maximum difference in frequency? So we're just going to subtract this from 2632, and that gives me a value of around 426.5, which is actually 430. So this should be the right answer. So yeah, so we have to subtract these two values over here. These are in hertz, by the way. Next step. This requires table for you to solve. So I'm just going to pause here and come back with the table. Okay, so guys, as I said, I'm using a table over here. This is a table that needs to be memorized by heart. Okay, I'm at a very different location, so yeah, the sound interference is going to be more, but then again, I'm going to be continuing this. We have few questions left, so let's see. The electromagnetic waves of frequency, the frequency is actually given to us. Let me just turn the screen one around. So that should do it, and apparently was disconnected, but now it is connected again. Nevertheless, I'm hoping that the recording goes as smoothly as possible. I'm just going to play it again. Okay, now listen to me very carefully. So we have 30 terahertz in a vacuum. So 30 terahertz must be equal to 30 multiplied by 10 raised to power 10 raised to power 12. Okay, so that should be 3 into 10 raised to power 13. So we need to verify this table over here. So electromagnetic waves, we are getting a very large value. So let's see. So it has to be terahertz. So tera means 10 raised to power 12. So we just need to look at this table, and it is from -1 up to 10 raised to power 6 or greater than this value. So greater than 10 raised to power 6 is definitely going to be but then again, electromagnetic frequency. Okay, so we need to find the wavelength first. Oh my god. So this is actually the frequency. So we need to find the wavelength because this is the table of wavelength. So let's see. 3 into 10 raised to power 8 meter per second is equal to frequency into that should be frequency into lambda. So frequency into lambda, and the frequency is actually 3 into 10 raised to power 8 is equal to 3 into 10 raised to power 13, and lambda should be equal to, just give me a minute, I have to arrange my calculator. It was already with me, but now I have moved to a different position. It is more lively because you can hear all the sounds and everything else. Anyways, 3 into 10 raised to power 8. This is then divided by brackets 3 into 10 raised to power 13, and approximately it gives me a value of 1 into 10 raised to power minus 5. Okay, so let's see. That is the wavelength, and that is in meters. So we need to look at this value. Where does it even occur? So it has to be, listen to me very carefully, it has to be between this value to this value. So it is actually infrared. This is actually infrared, or let's see, 1 into 10 is so this has to be infrared region. This is actually infrared region, so I'm just going to mark it as infrared. Okay, let's move on to the next question. The stationary wave is produced on a string that is unstressed between two fixed points that are a distance whatever apart. The speed of the waves on the string is 450 meter per second. What is the frequency of the oscillation of the stationary wave? So our target is first to find the wavelength. And looking at this, because we are getting a stationary wave, so these are the nodes, and nodes. So the nodes, so I'm just going to find the wavelength first. So half, okay, how many half wavelengths do we have? 1, 2, and 3. So 3 into lambda over 2 is actually equal to 1.35. So lambda should be equal to 2 into 1.35 divided by 3, and that gives me 0.9. So lambda is 0.9 and the speed is 450. So 450 is equal to 0.9 multiplied by the frequency. So 450 divided by answer should give me around 500 hertz. So that gives me the answer. Let's move on to the next question. A beam of laser light is directed towards a narrow slit. After emerging from the other side of the slit, the diffracted light then falls on a screen. What is the pattern of light seen on the screen? So the spreading is going to be in this way, horizontally. The spreading will happen horizontally. Okay, just give me a minute. Remember, the diffracted light then falls on a screen. We have a slit. It's a single slit, so that is one opening. So the spreading should be this way around, and so we are going to see this B option over here. Two waves, each with constant amplitudes, constant amplitude, interfere and produce an interference pattern. The pattern has minima at fixed points where the displacement is 0 at all times. Okay, which statement describes the two waves? Which statement is the two? They must be coherent and of the same amplitude. That is true. They must be coherent but not necessarily of the same. But we are seeing displacement is 0, so that means they must be of the same amplitude. They must be of the same but not necessarily coherent. They must be coherent. They must not be coherent. So this has to be A. Let's see. Light of wavelength, whatever is given, is incident normally on a diffraction grating. The angle between the second order is this, so we are going to divide this, and that's just going to be 40 degrees. So this is second order. What is the number of lines per meter of the diffraction grating? So first of all, we're going to find D. So we are going to be using D sine theta is equal to n lambda. That is going to give us the line separation, and 1 over line separation will give us the number of lines per meter. So D is equal, D multiplied by sine 40. So n is the order number, so this is going to be second order, and light wavelength is actually 5.5 into 10 raised to power minus 7. And if you're going to do this calculation, we're going to get the value of D, which we are going to inverse. So 2 into 5.5 multiplied by 10 raised to power minus 7, bracket closed, and divided by sine 40, and bracket closed. Yes, it is in degree mode, so I'm getting a value of D as 1.7 into 10 raised to power minus 6. So I'm just going to find 1 over this value, and I'm getting a value of approximately 5 into 8 into 10 raised to power 5 meters, lines per meter. So this is going to be the A answer. Okay. 4 diagrams. So electric field is not a part of your syllabus, and then this is also not part of our syllabus. What is the description of a Coulomb? Well, the electric charge of one electron. No, the electric charge transferred by a current of 1 ampere in 1 second. or the kinetic energy gained by this, the kinetic energy of an electron moving, the electric charge of one electron. No, that is not 1 coulomb. The electric charge transferred by a current of 1 ampere in 1 second. Let's see, Q is equal to IT. The electric charge transferred by a current of 1 ampere in 1 second. So that can be true. That is true. In 1 second. The kinetic energy gained by an electron accelerated through a potential difference of 1 volt. No, that cannot be true. The kinetic energy of an electron moving at a speed of 1 meter per second. No, that is going to be B. That is going to be definitely going to be B. Transferred by a current of 1 ampere in 1 second. So that is true. That is true. That is going to be the right answer. So it has to be B. Now next point, 34. 34 is going to be a battery of electromotive force. Okay. So a battery of electromotive force 10 volts and internal resistance 5 ohm is connected to a 5 ohm load resistor. So which change occurs when the 5 load resistor is replaced with a 50 load resistor? The current in the circuit increases. No, it has to decrease. The potential difference across the load resistor increases. Definitely yes. The power dissipated in the internal resistance of the battery increases. No, that is not true. It is going to decrease over here because the current has decreased. The total power dissipated in the circuit increases. The potential difference, let's just look at this factor that the current decreases. So no, that is not going to happen. That is not going to happen. So it has to be B. The graph shows how the variation with potential difference V of the current I for 3 circuit components. The components are a metal wire at constant temperature, a semiconductor diode, and a filament lamp. This is for the filament lamp. Z must be a filament lamp. And so obviously this leaves us with one option only. So B is going to be the right answer. This is a fixed resistor. And this is a diode basically. So yeah, the electromotive force of a cell is 6 volt. It has negligible internal resistance and is connected across a resistor. The potential difference across the resistor is also 6 volts. Okay. The EMF and the PD have the same numerical value but represent different processes. Which statement about the different process is correct? The EMF is the energy transfer from chemical to electrical energy in the cell. And the PD is the energy transfer from electrical energy to thermal energy in the resistor. That could be true. The PD is the energy transfer from chemical to electrical. No, that is wrong. The EMF is the energy transfer per unit charge. Okay, that makes more sense. From chemical energy to electrical energy, and the PD is the energy transferred per unit charge from electrical energy to, this is the absolute answer. So that is obviously per unit charge, because we know V is actually equal to W over Q. So work done or energy change per unit charge. A battery of negligible internal resistance is connected to 3 resistors as shown. The potential difference across each resistor is 2 volts. The current from the battery is 0.4 ampere, and you can see that it's 0.3. And the current through one of the resistors connected in parallel is this. The 3 resistors as shown, but they are not necessarily identical. What is the current through the other resistor connected in parallel? And what is the electromotive force of the battery? So electromotive force is actually going to be 4. It is going to be 4 because 2 plus 2 is actually 4. We just keep it as 2 volts over here, and so 4 and 4. But the current is the main problem. But then we can easily find it out. Let's see. We have 0.4 ampere flowing from here, and definitely it's going to split up. So 0.3 goes over here. So this is going to be 0.1. This was very easy question. 38. The battery of electromotive force 9 volts and internal resistance is connected to a fixed resistor of resistance 5 ohm and a potentiometer of maximum resistance 3 ohms as shown. The sliding contact of the potentiometer is moved over its full range of movement. What is the maximum value of the potential difference that is measured by the voltmeter? So the maximum value is going to be the potential difference across this entire resistance. So we are just going to be using the potential divider formula. So V out or V across 3 ohms must be equal to the EMF multiplied by the combined total resistance of the entire circuit, and that is going to be divided by 5 plus 3 plus 1. So let's see, 5 plus 4, 9. So 9 into 3 divided by 9. 9 cancels, so that is going to be 3 volts. So A is going to be the right answer. An unstable nucleus decays by emitting a beta positive particle. Which statement is correct? An neutrino is also emitted? No, neutrino is emitted. A neutron changes into a proton. Actually, the proton changes into a neutron, so that is not true. Mass energy is conserved. That is always true. Nucleon number is not conserved. It is actually conserved. So C should be the right answer. Which statement is not correct? An antineutrino is a fundamental particle. That is true. An electron is made up of a quark. That is not true. Neutrino is a lepton. Definitely true. A neutron is composed of 3 quarks. That is also true because it is a baryon basically. So B has to be the right answer. So we did all these questions, and let's just move on to the next paper. I'll share this video later. I'm going to be sharing this video, and then I'm going to be uploading another video after this. Anyways guys, take care, and Allah Hafiz.